Today we're going to learn how to solve a system of linear equations using matrices. So we're going to start off with a system of linear equations, and we're going to write what's called an augmented matrix with the system of linear equations. We write the augmented matrix by listing each one of the coefficients of the equations in the augmented matrix along with the constant. So the 3, the 1, the 2 is located here, 3, 1, 2. And then the constant 31. We have a 1, a 2, and a 19 located in the second row. We have a 1, a 3, a 2, and a 25 listed in the third row there. So what we do with that augmented matrix is add rows together and replace rows and multiply rows by numbers and eventually come up with what's called the reduced row echelon form of the augmented matrix. After we get the reduced row echelon form of the matrix, that represents these equations right here. Okay? So you can see here that there's no x in the third row here. There's no x and no y value there. So that's like saying a 0x plus 0y plus 1z equal 4. So that's why here in the third row of the row echelon form we have a 1 and a 4. Okay? And then in the second row we have no x value. So that's like saying a 0x and then a plus 1y plus 3z is equal to a 9. So that's why we have the 0, 1, 3, 9 there. And then the top row here we have all the coefficients and the negative 19 constant value. Now you guys, the advantage of having this row echelon form is because once we have the z value and we have one equation that only has y and z, we can plug in that z value to figure out the y. And once we have the y and the z, we can plug into the first equation to solve for the x value. Okay? So I'm going to show you guys how to deal with this row echelon form today. How to put our system of equations into the augmented matrix and deal with the row operations to come up with the row echelon form. And then eventually we're going to go to what's called reduced row echelon form, which is a matrix we can look at and specifically identify the x and the y and the z just by looking at the matrix. So let's jump to some different things that we're going to see with the row operations. Like I said, you don't have to write this down. I'll throw this on the website, okay? But my guess is you probably won't need to visit this too often because after today you're probably going to be pretty decent with this. So I'll go ahead and read through this. If you have questions, just go ahead and ask me. It says these row operations produce matrices that lead to systems with the same solution set as the original system. So two rows of a matrix may be interchanged. This is the same as interchanging two equations in a linear system. So you guys, if you had one equation on top of another, it doesn't matter if you flip those around, right? Okay, same thing with matrices. You can flip rows around and it's okay, it doesn't matter. All right? Number 2 says the elements in any row may be multiplied by a non-zero number. This is the same as multiplying both sides of an equation by a non-zero number. So with an equation, you can multiply both sides of that equation by some number, right? Same deal with matrices. You can multiply the entire row by a number. That's totally legitimate. It's similar to just multiplying an equation on both sides by a number. Okay. The elements in any row may be multiplied by a non-zero number, and these products may be added to the corresponding elements in any other row. This is the same as multiplying both sides of an equation by a non-zero number, then adding equations to eliminate a variable. So what we're going to see is that we're going to add two rows together, and we're going to replace one of the rows with the resulting row that we get. So we'll take, say, a row 1 and a row 2, add those two rows together, and then replace either row 1 or row 2 in the matrix with the new row that we came up with. Okay? So there is an order of going about this whole process that is definitely something that you want to pay attention to. So I'll go ahead and read through this and kind of go step by step here. But like I said, you guys, when you're finding the row echelon form of an augmented matrix, you definitely want to go in a specified order. Otherwise, you'll come up with some crazy looking matrices that might be kind of difficult to deal with. So first one says write the augmented matrix for the system. That's an easy one. And then use the matrix row operations to simplify the matrix to one with ones down the diagonal from upper left to lower right and zeros below the ones. So the first thing that we want to do is get a 1 in the upper left hand corner. That's the very first thing we want, is just a 1 in the upper left hand corner. Once we have that 1 in the upper left hand corner, we want to perform our row operations and somehow get zeros below the 1s. After we get the 1 and then the zeros below the 1, we go for the 1 in the, this would be row 2, column 2, okay? So we go in that order. We get the 1 and then the zeros below, and then we get the 1 in the row 2, column 2. After we get that 1, we go for the 0 below that 1. After we get 0 below that 1, then we go for the last 1 there, okay? If we go in that specified order, things work out pretty nicely, okay? So our goal, our ultimate goal, is to first find the row echelon form, because this is going to enable us to figure out what those unknown values are. After we find the row echelon form, we're going to go for what's called the reduced row echelon form, and that's when we end up with zeros in these spots here. If we have zeros in those spots there, we could just look at the matrix and identify what the x and the y and the z values are equal to. So let's go ahead and start off with a problem. Example number 3. So first thing we're going to do is write the augmented matrix, which means that we're going to list each one of these coefficients: 1, -2, 1, and the constant 7, and then the 3, the -5, 1, and 14, and then the 2, the -2, -1, and then 3 there. So that's our first thing we got to do, is write the augmented matrix. I don't really like drawing that line there. The examples I showed prior do put the line, but you don't have to put that if you don't want to. So the first thing we want to do, you guys, is we want to get a 1 in the row 1, column 1, right? We already have the 1 in row 1, column 1, so we don't need to worry about that. That's kind of nice. And you guys remember that you can flip rows around, right? So if you know, I had row 1 where row 2 is located, I would just flip them around and write the augmented matrix that way, okay? So just remember that you can flip rows around. That's okay. So now what we want to do is we want to go for a 0 below the 1. So I want to add a couple rows together and try and eliminate that first spot. So I'm going to multiply. I'm going to go for multiplying row 1 by a -3, and that gives me a -3, 6, a -3, and a 21, and I'm going to add that to row 2. And I'm going to add straight down. So I have a 1, a 0, a 1, a -2, and then a -7 there. So if I make any mistakes, you guys please let me know, because if you make the tiniest little error, it just throws everything off. So that was kind of nice, because I added straight down, and not only did I get a 1 in that first spot there, but I'm sorry, a 0 in that first spot, but I got a 1 in that second spot there. So I kind of killed 2 birds with 1 stone. I'm going to replace row 2 with the resulting row that I just came up with. So I'm going to rewrite row 1 and then I'm going to replace row 2 with the new row that I just came up with. All right. Remember that you can only you replace either row 1 or row 2, right? You work with those two rows, so you can only replace one of those two rows. Okay. So from here, I want to get a 0 below the 0 here, right? So what I'm thinking I should do is multiply row 1 by a -2 and add it to row 3. So I'm going to multiply row 1 by a -2 and then add it to row 3. So I get a 1, -2, 1, 7. And I'm going to add that to row 3. Add straight down. Oops, you know what I did? I rewrote the row without even multiplying. Okay, so we have a -2 for a -2 and minus 14 there. Okay, a little better, right? So then we add straight down and we get 0, 2, 3, and minus 11. So we are going to replace row 3 with the new resulting row. So we have row 1, and then row 2, and then row 3. Okay. So now what I want to do is, because I have this, the 1, the 0, the 0, and then actually I have a 1 in the row 2 column 2 spot, I need to now go for a 0 below that 1 there. So I'm going to add row 2 and row 3 together, and I'm going to multiply row 2 by a -2. So we have row 2 multiplied times a -2, and we're going to add that to row 3. So now we have 0, -2, 4, and 14. We're going to add that to row 3. And we add straight down, we get a 0, 0, 1, and 3. So that was really awesome because adding those two rows together gave us a 0 like we wanted, but it also gave us a 1. So it in one step we killed two birds with one stone, so to speak. That's saying, right? So we have the row echelon form right now because we have the diagonal of the 1s. So I think at this point it's kind of nice to reflect on the equations that the row echelon form represents. So I'm going to rewrite those equations to just sort of reflect on that right now. We have the first row representing a 1x minus 2y plus 1z is equal to 7. And then row 2 we have a 0x, so I don't need to write that. And then we have a 1y minus 2z equals a minus 7. And then we have a 0x, a 0y, and then a 1z is equal to 3. So that's what our row echelon form represents there. Okay? So now that we have the row echelon form, what I want to do with you guys is come up with the reduced row echelon form. And the reduced row echelon form, remember, shows the matrix, and you can identify what the x and the y and the z value is just by looking at the matrix. So I'm going to erase a few things, and I'm going to pull the row echelon form to the top. One thing I should state is that sometimes when you're working on a matrix, on converting a matrix into row echelon form, and you're working next to a person who's working on the same exact matrix, sometimes the person you're sitting next to will come up with a different form of the row echelon form. And that's okay. And the very bottom row should be equal to the same thing, but row 2 and row 1 could be different, okay? It's okay because if you're doing everything correct, when you come up with the reduced row echelon form, you should come up with both of the same exact matrices. But let's go ahead and erase and start fresh finding the reduced row echelon form. Okay, you guys, so remember what we're looking to get right now is the reduced row echelon form, which means that we're looking for zeros in these spots here. If we have zeros in those spots there, we'll be able to identify X, Y, and Z just by looking at the matrix. But let's go ahead and perform some row operations in order to obtain those zeros. So what I want to do right now is I want to work my way back up here, and I want to go for a 0 right now where the -2 is located. So I'm going to add my row 2 and row 3 together, and I'm going to multiply row 3 by a 2. So row 2 we have a 0, 1, -2, -7. And then row 3 we have a 0, 0, 2, and a 3. 6, thank you. And we add straight down, we have a 0, 1, 0, -1. And I'm going to replace row 2 with that new row. So we have 1, -2, 1, 7. And we have a 0, 1, 0, -1. And then we have a 0, 0, 1, 3. So right now I can look at this form of the matrix and say, oh, y is equal to -1 and z is equal to +3. Now I need to figure out what x is equal to. And so I'm going to add row 3 and row 1 together. I'm going to multiply row 3 by a negative. And so we have a 1, -2, 1, 7, and a 0, 0, -1, -3. We're going to add straight down, so we have a 1, -2, 0, and 4 there. So now I'm going to replace that resulting row into row 1, and we have a 1, -2, 0, 4, 0, 1, 0, -1, and 0, 0, 1, and 3. So now at this point, we have one more 0 to go. We want to get rid of that -2. Getting rid of the -2 will give us the reduced row echelon form. So we're going to combine row 1 and row 2 together, and we're going to multiply row 2 by a 2, and now we have a 1, -2, 0, 4, and a 0, 2, 0, -1 times 2. And we add down, and that gives us a 1, 0, 0, 2. So that tells me that x is equal to 2. X equals 2. And now we have our reduced row echelon form of the matrix. Well, it was a long process, but the better you get at it, the faster you can go. And you don't have to write out every single little step, right? When you're performing for me, I'm going to want you to write every step so I can track what you're doing. But this will go faster and faster and faster. Now, you guys, one thing I do want to show you is how to actually find the reduced row echelon form on a calculator. Last Friday, I showed you guys how to use an inverse matrix to find the unknown values of a system of equations, and we had to type in two matrices, right? We can actually use just one button with our calculator, which is kind of nice. So I'll show you guys actually how to solve for x, y, and z using the matrix button, and just one button on your calculator. Okay, so let's go ahead and turn on that calculator. And so I'm going to go to second. Uh-oh. My calculator's not performing for me on the recording. It's a little bit embarrassing. All right, so we're going to go ahead and find our reduced row echelon form by heading second and then matrix, and then we're going to scroll over to the edit button, and we're going to edit this 3x3 into a 3x4 matrix. So I typed in 3x4, and then I go down and it gives me a 3x4 matrix. And I'm going to need one of you to read me off those numbers, please. So it's a 1, 1, 0. We'll stick with Claudia. 1, 0. No, kiddo. You're giving me the augmented matrix right now. The first one, yes. So I'm sorry. We'll go with Jessica now. 1, -2, 1, 7, 3, -5, 1, and 14. And then we go to the third row, which was 2. So 2, -2, -1,
3.
and 3. Okay. So now that we have the augmented matrix input in our calculator, we're going to go to second and then quit. Second mode, which is quit, takes us to the blank screen. So now from here, we need to go back to the matrix button, and we need to go to the middle button, which is math, and then we're going to scroll to the RREF. So RREF, that stands for reduced row echelon form. So we click on that, and that sends that function to the blank screen. And then from here, we need to do the second matrix, and then click on number 1A for the name. That sends matrix A to the blank screen. Close the parenthesis, click enter, and it makes the reduced row echelon form out of your augmented matrix. So solve for x, y, and z pretty darn easily, right? Well, now you know how the calculator thinks. The calculator goes through all these row operations and substitutes rows to come up with that solution. So being smart people like yourself, you would want to know how the calculator thinks so you can actually program the calculator one day, right, Nick Zinner?